Hello, everyone, and welcome to Times of AI. And today we'll be looking at some of the research that's been done to study the way the large language models have been progressing and constantly improving. And this research paper takes a deep dive into the world of algorithmic efficiency and exploring how language models are learning to do more with less. So here's a research article from MIT CSAIL Lab, from recurrent networks to GPT-4, measuring algorithmic progress in language models, which links to this paper, Algorithmic Progress in Language Models. You can think of progress in language models like scaling a mountain of complexity. The more powerful these models become, the higher they climb. But what if we told you that they are scaling this mountain faster and faster? And this study uses a fancy tool called augmented scaling law, which is explained by this equation. And what it tries to do is it's trying to measure the progress of the models using this scaling law, and this they even define terms like effective data and effective model size to track how much less data and computing power these models need over time to reach the same level of performance. The results are really impressive. The study suggests that language models are becoming twice as efficient every 8 months on average. Here is a comparison figure where roughly the language models are becoming twice powerful in or efficient in roughly 8 months, whereas some of the other use cases you can see are mostly slower, or they also depend on the amount of data that's being fed into them. But throwing more computing power at any problem seems to be a bigger driver of performance gains lately compared to pure algorithmic innovation. So, why are we seeing this shift towards compute scaling? One reason could be that the advancements in building powerful computers are happening faster than breakthroughs in new algorithms. And it's like having a powerful engine but needing to fine tune the way we use it to get the best performance. So here are the results. And of course, it's not all sunshine and rainbows. The study acknowledges limitations like availability of high quality data and variations in training methods. It's important to distinguish between data quality improvements and pure algorithmic efficiency gains. Additionally, factors like how much text the model sees at once, which is the context length, can influence the results. Selecting the best model. Now, you might be curious about how the researchers actually analyzed all this data, and the study involved a rigorous process of selecting the most suitable model for analyzing language model evaluations, and they considered various versions of a mathematical equation and tested them against a data set of hundreds of language models. Roughly 200 language models were tested, and this meticulous approach ensures the results are as reliable as possible. uh, Beyond the numbers, but what does this all mean for the real world? Faster learning language models have the potential to revolutionize how we interact with technology. Imagine chatbots that can understand your questions with greater nuance, or machine translation that reads like as it was written by a human. The possibilities are truly exciting. Although challenges remain, the future of language models look bright, and understanding the balance between algorithmic progress and computational resources is crucial for pushing these models even further. As we refine our algorithms and build even more powerful computers, language models will continue to learn and adapt at an incredible pace. So there you have it. Language models are making impressive strides driven by both algorithmic advancements and the ever-growing power of computing. This research helps us understand the factors at play and paves the way for even more sophisticated language models in the future. Let us know in the comments what you think and what excites you most about the future of language models. Thank you.